The first year of the 20th century saw the Wright Brothers' first attempt at a man-carrying glider. Their rudimentary control system worked when flown as a kite. However, the wings did not generate enough lift to carry a man aloft. 1 year later, using aerodynamic tables compiled by Samuel Langley and Otto Lilienthal, the brothers constructed a new, larger glider. Its flight was only marginally successful. Using a self-designed wind tunnel, the brothers analyzed 200 model wings to verify that the tables they had been using were incorrect. By painstakingly computing their own aerodynamic tables, the Wrights were able to build a glider that almost doubled in lift efficiency. The ability and willingness to recalculate flawed tables led to the first successful flight of a controlled, powered, heavier-than-air flying machine. Autopilots, Norden bomb sights, early heads-up displays, and auto-leading gun sights are all types of primitive analog computers. Calculating machines were used in the 1930s to perform complicated calculations of airflow over airfoils. World War II saw the invention of the first digital computer, the ENIAC. This massive machine utilized vacuum tubes as its switches and was programmed by rewiring the entire machine. Slow by today's standards, this machine could calculate in seconds what would take hours to perform manually. Cold War-era Air Force requirements drove many of the early developments in computer miniaturization and usability. The Thor Able guidance computer was the first fully transistorized digital computer. Early warning systems, such as SAGE, saw the development of human-computer interfaces like the cathode ray tube and light pen. In 1958, 2 Air Force scientists working at Wright Field in Dayton, Ohio, secured funding from AFOSR for Dr. Jack Kilby. In September of that year, Kilby demonstrated the first functional integrated circuit. This IC is a complete electrical circuit made up of various components, miniaturized and printed onto a single semiconducting chip. Within a decade, the integrated circuit was used in the guidance system of the Minuteman ballistic missile and the Apollo guidance computer. In 1961, Dr. Douglas Engelbart was awarded a contract by AFOSR for his research on the potential of computers to assist in complex decision-making. His report served as a roadmap for developing computer technologies. This was followed in 1964 with the introduction of the first computer mouse, the most widely used computer input device after the keyboard. The Air Force Research Laboratory now uses the very technology it helped pioneer to continue its research and development. Since its 1996 inception, the AFRL DoD Supercomputing Resource Center has supported the warfighter by combining world-class supercomputers, secure interconnects, and software and services. This allows for modeling, simulation, and evaluation of diverse programs such as quantum chemistry, bio-inspired flight characteristics, condensation during supersonic flight, scramjet design, and other computationally heavy research. The first digital computer could add 5,000 numbers in a single second. Its first test problem was a series of computations for the development of the hydrogen bomb. Today's fastest AFRL supercomputer can perform 5,620 trillion floating point operations per second. Air Force research jump-started the modern computer revolution, and AFRL research continues to benefit from those pioneering developments in the ever-expanding, ever-changing world of digital calculation.